Hey guys, Dr. Brown here with Kubo Math, and tonight we're looking at the integral of cosine cubed dx. So you recall the sessions we've been doing. We had sine squared, sine cubed, sine raised to the nth power, which I thought if we just had that one we could plug in any 2, 3, 4, whatever n happened to be. But we're doing the same now. We've done the cosine squared. Tonight we'll do cosine cubed, and then in the next few nights I'll post one for cosine raised to the nth, and then we'll move on to tangent and cosecant, secant, and all of those. So now I'm having a bit of a software issue with my microphone, so hopefully this comes out okay. If not, I apologize. We'll get that fixed. Okay, integral of cosine cubed x dx. I'm going to rewrite that and make that into a cosine x cubed dx. Same, it just helps me. I don't know if it helps you, but when I take derivatives and all, and if I have my exponent out like that, it just makes more sense, because that's the way we do it with everything else except trig functions. Okay, now let's expand this. This could be listed as cosine x squared times cosine x to the first power dx. Cosine squared x is the 1 minus sine x squared times cosine x to the first power dx. Now if I were to distribute the cosine x onto everything else here, let me put a brackets about that. So now I have the integral of cosine x times 1, which is just cosine x dx, minus the integral of sine x squared cosine x dx. Okay, well, if I were to integrate this one, we know this is just the derivative of cosines minus sine, so the integral is sine, so this is just sine x. Okay, minus, what do we have going on here? Let's let, we'll do it up here, u equals sine x. Okay, what is derivative of sine? Well, that's cosine x dx, chain rule. Now let's isolate dx, so we're going to divide both sides by cosine x, so du over cosine x equals dx. So now then, what do we have here? We have u is sine x, so we have u to the second power, and then we still have our cosine x, replacing dx with du over cosine x. And you'll notice cosines cancel themselves, so now we have the integral of u squared du. Of course, we've already finished this one. It's sine x. So sine x minus, this would be u squared plus 1 equals 3 divided by 3. So I have 1/3 and u to the u cubed, but u is, u is sine x. So I have sine x cubed. Now, having a cubed term is okay for me, but when we're looking in many textbooks, they want us to reduce that just a little. So let's go up here. We have sine x minus 1/3 sine x squared times sine x. Okay, that's my sine x cubed. Okay, well, what is sine squared x? It's 1 minus cosine squared. So now I have sine x minus 1/3 times 1 minus cosine x. I'm going to put the squared term right here for the moment. Sine x. Okay, so what does that give me? Sine x minus, distribute the sine x and the 1/3 to the inside, so I have minus 1/3 sine x. Now minus times, the negative times negative gives me a positive 1/3 sine x cosine squared x. Well, let me factor out a sine x, as I have one in each term. Sine x times 1 minus 1/3 plus 1/3 cosine squared x. Well, 1/3 minus 1 minus 1/3, we can take care of that. That gives us 2/3 plus 1/3 cosine squared x. Well, now I can factor a 1/3 out. 1/3 sine x times 2 plus cosine squared x plus c. And that was the form that they wanted this thing to be in. Okay, the integral of cosine cubed is 1/3 sine x times the parentheses of 2 plus cosine squared x plus c. Next video we'll take this cosine to the nth power, solve for that, and then we'll take this answer plus the one we had in cosine squared x and see if we plug in a 2, n equal 2 or n equal 3, and get the same results. Okay, why are we doing this? Together we're trying to build a better tomorrow and do that through math. That's all for now, and we'll talk to you next time. Thanks.